Imagine a day where you can simulate a world so perfectly with life forms, humans, so well that you can recreate every single neurosynaptic thought you could have, but now you're in the simulation on the computer.
MIT just found the receipts. For years, people have joked about the Matrix and living in a simulation, but it is not a joke anymore. A physicist named James Gates was studying the fundamental equations of the universe when he found something that made his blood run cold.
We have discovered that there are mathematical structures that are indistinguishable from error-correcting codes, as does occur in digital information transmission.
Buried deep in the math of super-symmetry, he found a string of ones and zeros. It was computer code. Specifically, it was browser code. And now, a new discovery suggests this code is not just running the universe, it is actively deleting parts of it to save space.
The backup system of reality. Let me be crystal clear about what we are dealing with here, because it is easy to dismiss this as science fiction. This is not some fringe theory from a dark corner of the internet or a Reddit thread that went off the rails. These are peer-reviewed discoveries from the most prestigious academic institutions on the planet. We are talking about the Massachusetts Institute of Technology, the Institute for Advanced Study, and the University of Portsmouth. The people involved are Nobel Prize contenders, not conspiracy theorists. And what they have found changes absolutely everything we thought we knew about where we are and what we are doing here. Daniel Harlow, currently a professor of physics at MIT, published a paper that is quietly causing an existential crisis in the scientific community. He was looking into a concept called the ad-CF correspondence. Now, I know that sounds like a mouthful of academic jargon, but stick with me, because understanding this is the key to seeing the bars on the cage. This framework is one of the most powerful tools physicists have to understand the universe. It connects two completely different types of theories, acting like a translator between languages. But when Harlow looked closer at how this translation worked, he realized it functioned exactly like a quantum error-correcting code. In plain language, the universe has a backup system. Think about how your smartphone works. You store thousands of photos, messages, and apps on it. If a single pixel in a photo gets corrupted, maybe a 1 flips to a 0, the phone does not just show you a broken image. It has algorithms running in the background that look at the surrounding data and reconstruct the missing piece. That is error correction. It keeps the system stable. It stops the digital world from dissolving into static. Harlow proved that space-time does the exact same thing. Information about what exists in any region of space is stored redundantly. It is woven into the very structure of reality, so that if part of space were to be destroyed or corrupted, the information would not be lost. It is backed up automatically by the geometry of the universe. In the year 2015, Harlow and his colleagues built a model they called the Happy Code. It was a network of pentagons representing space-time. And when they analyzed how information flowed between these shapes, they realized it was identical to the systems engineers use to protect data in quantum computers. But here is the catch. Why would a natural, organic universe need a backup system? A rock does not need error correction to be a rock. A river does not need code to keep flowing. Natural things just are. They are messy, they are chaotic, and they exist without a safety net. Code, on the other hand, is artificial. Code is a language. Code implies a coder. If nature has a built-in mechanism to prevent data corruption, it suggests that reality is not physical at all. It is digital. And if it is digital, it means we are running on hardware. But what happens when that hardware starts to run out of memory? This discovery by Harlow was massive, but it was essentially theoretical. It was a mathematical proof that space acts like code. But years before Harlow published his proof, another physicist had already found something buried in the equations of physics that was far more literal. He found something that should not exist in a natural world. He found computer code. Not a metaphor, but actual strings of ones and zeros organized into specific, recognizable patterns that software engineers use every single day. And the implications of that are terrifying. The browser code buried in nature. The man who found the smoking gun is named James Gates. He is a theoretical physicist who wrote one of the very first doctoral dissertations at MIT on supersymmetry. He is not a guy who looks for ghosts. He deals in hard math. He was studying the fundamental equations that describe how the smallest particles in the universe, quarks and leptons, interact with each other. He was just doing the mathematics, trying to balance the equations to see how the universe holds itself together at the subatomic level. But as he drilled deeper into the math, looking at these complex geometric structures called adinkras, he noticed a pattern. It was a sequence that looked familiar. It wasn't just random numbers, it was a specific, repeating structure. When he isolated it and showed it to his team, the room went silent. They were looking at doubly-even self, dual linear binary error correcting block codes. That is the technical name. And if that sounds like something a software engineer would build at Google or Microsoft, that is because it is. These are the same type of codes from the family first developed by Claude Shannon and Richard Hamming in the 1950s. These are the codes that allow your web browser to function. They are the reason you can watch a YouTube video without the pixels scrambling every time your internet connection dips. They are designed to filter out noise and ensure accurate transmission of data. Gates found this exact same code written into the fabric of reality. He later said in an interview, error-correcting codes are what make browsers work. So why were they in the equations I was studying about quarks and leptons? This is the moment where you have to stop and ask yourself a very serious question. If you walked onto a beach on a deserted island, and you saw "Help me" written in the sand, you would not assume the wind and the waves wrote it. You would assume a person wrote it because it carries information. It carries intent. James Gates found the universe's version of "Help me" written in the math of electrons. He presented this finding at the Isaac Asimov debate in the year 2012. The panel included Neil deGrasse Tyson, who is usually the first person to debunk wild theories. But when Gates laid out the math, when he showed that the underlying operating system of our reality includes the same error correction algorithms we use in our telecommunications, even Tyson had to pause. He said this was the moment he started taking the simulation hypothesis seriously. Because in a natural universe, there is no reason for this code to exist. So, let me lay this out clearly so we are on the same page. One MIT physicist proves space-time is structured like an error-correcting code. A different physicist finds literal computer code embedded in the equations governing matter. These are two independent discoveries, using different methods in different fields, leading to the exact same conclusion. Reality has source code. But the question nobody wants to answer is, who wrote it? And the reason they do not want to answer it is because of the glitch. If this is a simulation, then there are parameters. There are settings. And if you have ever played a video game, you know that the settings are the most important part. You have gravity, light bloom, rendering distance. If you change one value by a tiny amount, the game breaks. The physics engine goes haywire, cars fly into the sky, and the character falls through the floor. Our universe has settings too. And when you look at how precise they are, it stops looking like a coincidence and starts looking like a setup. The impossible settings menu. If you built a simulation, the most important thing you would need to get right is the constants. These are the fundamental numbers that dictate how the universe behaves. The physicist Martin Rees spent his career cataloging them. There are 6 fundamental numbers. If any of these numbers were different by less than a fraction of a percent, none of this would exist. No stars, no matter, no you. And the precision required to set these numbers is frankly impossible to explain away with luck. First, you have the cosmological constant. This controls how fast the universe expands. It is fine-tuned to 1 part in 10 to the power of 120. That is a 1 followed by 120 zeros. If this number were slightly higher, the universe would fly apart so fast that galaxies could never form. Stars would never ignite. It would just be a cold, dark, expanding soup of nothingness. If it were slightly lower, the universe would collapse back in on itself within seconds of the Big Bang. It had to be exactly this number. Then you have the strong nuclear force. This determines how tightly protons and neutrons bind together in the nucleus of an atom. If this force were just 2% stronger, hydrogen would burn up instantly. There would be no hydrogen left in the universe, which means no water and no long-lived stars like our sun. If it were 2% weaker, nothing heavier than hydrogen could form. You would have no carbon, no oxygen, and no periodic table. Life as we know it is balanced on a razor's edge of exactly 2%, and that is putting it lightly. The gravitational constant is fine-tuned to 1 part in 10 to the power of 34. If gravity were slightly stronger, stars would burn through their fuel in a few million years, dying out before life could evolve. If it were weaker, matter would never clump together to form planets. You would just have diffuse gas floating in the void. No solid ground to stand on. No Earth. No Mars. Just dust. But the real kicker, the one that made even Stephen Hawking pause, is a calculation by Roger Penrose. He calculated the probability that the initial conditions of the universe, the state of entropy at the moment of the Big Bang, would land exactly where they did by pure chance. The result he got is a number so large it breaks the human mind. The chance is 1 in 10 to the power of 10 to the power of 123. To write that number out in full, you would need more digits than there are particles in the observable universe. If you wrote a 0 on every single atom in every single galaxy, you would run out of atoms before you finished writing the number. It is, mathematically speaking, the single most improbable event that has ever been calculated. And yet, it happened. We are here. The universe is stable. The settings are perfect. Now, physicists generally have 3 explanations for this. Option 1, we got lucky. Impossibly, absurdly lucky. If you believe that, I have a bridge to sell you on Mars. It is like winning the lottery every single day for 1 billion years in a row. Option 2, infinite universes. This is the multiverse theory. It says that every possible combination of numbers exists somewhere in an infinite foam of bubbles. We just happen to be in the one bubble where the math works. It is elegant, it solves the problem, but it is completely untestable. We can never see those other universes. Option 3 is the one that keeps physicists up at night. Someone set the values. Someone went into the config files and adjusted the sliders until the system was stable. And if you combine that with the discovery that the equations governing matter contained literal computer code, and with the finding that space-time itself is structured like error correction, then these constants are not miracles. They are parameters. And the fact that they are so absurdly precise, that is the glitch. In a natural universe, these numbers should be messy. They should be random. Instead, they look like someone spent a very long time getting them right. But hold on, because we need to go deeper. MIT didn't just find code in the equation. They found something that suggests the universe isn't just running code, but that the universe is the computer. It is not a simulation inside a computer. Reality itself is the machine processing the data. And the output of that calculation is what we call existence. Universe computing itself. Seth Lloyd, also at MIT, is the designer of the first feasible quantum computer. He looked at the universe not as a physicist, but as a computer engineer. He calculated that since the Big Bang, the universe has performed 10 to the power of 120 operations on 10 to the power of 90 bits of information. Every particle interaction, every collision between every electron and photon was not just a physical event. It was a logical gate operation. It was a computation. He put it this way: atoms and electrons are bits. Atomic collisions are ops. Machine language is the laws of physics. So, what is this universe-sized computer calculating? It is calculating its own dynamical evolution. As the computation proceeds, reality unfolds. Reality does not contain information. Reality is information being processed. The chair you are sitting in is not solid matter in the way we used to think about it. It is a calculation. The light hitting your eyes is data being rendered in real time. And just when you think you have a handle on this, Nima Arkani Hamed at the Institute for Advanced Study discovered something that removed the floor from under everyone's feet. In the year 2013, he found a mathematical object called the amplituedron. This is a geometric shape that encodes all particle interactions in the universe. It simplifies calculations that used to take thousands of pages of algebra into a single geometric volume. But the terrifying part is not the math. It is what is missing from the math. The amplituadron calculates the outcomes of particle collisions without any reference to space or time. Space and time are not in its equations. They are not input variables. Instead, space and time emerge from the geometry like a shadow projected from a higher dimensional object. Arkani Hamed said, "The object is basically timeless." This means that the 3D world we walk around in and the time we feel passing are not fundamental. They are user interfaces. They are the desktop icons on the screen, simplifying the complex code running underneath. By the year 2024, his team had extended this concept into a field called surfaceology. And here's the crazy part. It works for real particles, not just theoretical ones on a chalkboard, but the real particles crashing into each other at the Large Hadron Collider. They are inching closer to proving that everything we experience, every moment, every touch, every sight, is being generated by a structure that exists outside of time. So, where does that leave us? We have code in the equations. We have error correction in space-time. We have the universe computing itself. We have space and time emerging from a timeless geometry. Every layer you peel back, there is another layer underneath. And they all say the same thing. Reality is running on something. And we can see the edges of the program. But there is one more discovery from the year 2025 that either confirms everything I have just told you or destroys it entirely. And this one suggests that the computer is trying to save memory. Great data deletion. In the year 2023, a physicist at the University of Portsmouth named Melvin Vopson published something controversial. Not everyone in physics is convinced yet, but if he is right, it changes the game. He called it the second law of infodynamics. Now everyone knows the second law of thermodynamics. It states that entropy, or disorder, always increases. Your coffee gets cold. Your room gets messy. Stars burn out. The universe marches inevitably toward chaos. Vopson's law says the exact opposite happens with information. He argues that information entropy over time decreases. It gets more organized. It gets more compressed. The universe is actively deleting junk data. He tested this against genetics and found that mutations, which Darwin said were random, actually follow a pattern. They consistently minimize information entropy.
DNA is not mutating randomly. It is being optimized.
It is like the code is being cleaned up with each generation. He applied this to physics and found that the universe's obsession with symmetry, the reason snowflakes are symmetrical, the reason orbits are elliptical, is not just about beauty. It is about data compression. Symmetrical shapes require less data to describe than asymmetrical ones. The same way a programmer uses compression algorithms like zip files to reduce redundancy and maximize efficiency. The universe compresses matter into symmetrical shapes to save on computational power. And then, in the year 2025, Vopson published a paper that connected it all. The title is Gravity Evidence of a Computational Universe? His argument is that gravity, the force that holds you in your chair right now, might not be a fundamental force at all. It might be an optimization process. When matter clusters together, information entropy decreases, and the system becomes more efficient to render. Gravity might be the universe's way of tidying up, reducing the computational load on the processor. His words were, a super-complex universe like ours, if it were a simulation, would require built-in data optimization and compression in order to reduce the computational power and data storage requirements. This is exactly what we are observing all around us. Basically, the universe is running a defrag. It is zipping files. It is clearing the cache. So, let me stack this up for you. We have error-correcting code in the laws of physics to prevent crashes. We have space-time structured as a backup system. We have the universe computing its own existence. We have space and time generated from a timeless source. We have constants tuned to impossible precision. And now, we have evidence that the universe actively compresses and optimizes its own data to save RAM. Every single feature of reality matches exactly what you would expect to find inside a sophisticated computer program. And then, just when the simulation theory looked like it had won, a team of physicists stepped in and said, "No, you are wrong." And here is the proof. In October of 2025, Dr. Amir Faisal at the University of British Columbia, alongside theoretical physicist Lawrence Krauss, published a paper claiming to mathematically prove the universe cannot be a simulation. Not that it is unlikely, but that it is impossible. Using Gödel's incompleteness theorem, they argued that reality requires non-algorithmic understanding, a form of truth that exists beyond computation. Since every simulation is algorithmic by definition, it follows a set of programmed rules. They concluded the universe cannot be one. Krauss added that the fundamental laws of physics cannot be contained within space and time because they generate them. He basically said, case closed. Except there is a problem. There is a glaring issue with Faisal's proof, and it is a big one. Now, to be fair, Faisal has a point. If the universe generates its own laws, those laws should be complete. That is solid logic. But his argument assumes that whatever built the universe must follow the same rules as the universe itself. He assumes that the simulator is bound by the same limitations as the simulation. But think about that for a second. When you play a video game, the characters inside the game cannot break the rules of the game code. They cannot walk through walls unless it is programmed. But you can. You exist outside the game. The game's limitations are not your limitations. If something built this universe, it does not have to be algorithmic. It does not have to follow Gödel's rules or our laws of logic. Those rules apply to systems within our mathematics, not to whatever exists outside of it in the base reality. And in December of 2025, David Wolpert at the Santa Fe Institute proved something even stranger that muddies the waters further. He showed that if a universe can simulate ours, nothing prevents ours from simulating that universe back. The two become mathematically indistinguishable. There is no higher reality, no base layer. The hierarchy collapses, and you are left with infinite chains of simulated universes that are all fully consistent. One team proves the universe cannot be simulated. Another proves it can be simulated infinitely. Both were peer-reviewed in the same year. The year 2025 did not answer the question, it made it exponentially more confusing. And that confusion brings us to the part no one is talking about. The real discovery is not whether we live in a simulation. The real discovery is that the question itself might be wrong. Harlow proved space-time is structured like error-correcting code, but he never said a person wrote it. The structure could be self-emergent, like a crystal growing. Gates found computer code in the equations, but as mathematician Stephen Wolfram pointed out, these codes appear in pure mathematics on their own. You do not need a programmer. You just need logic. Lloyd proved the universe computes, but computation might just be what physics looks like when you describe it in terms of information. Here is what really keeps me up at night. What if the code is real, but there is no coder? What if error correction is not a design feature, but a survival feature? Think about evolution. Animals that cannot survive die off. Maybe universes work the same way. The only universes that can exist, that can hold together long enough to form stars and planets, are the ones that automatically protect their own information. Every universe without error-correcting code simply falls apart. It crumbles into noise before it even begins. Max Tegmark, also at MIT, proposed exactly this with his mathematical universe hypothesis. He says our universe is not described by mathematics. It is mathematics. Every self-consistent mathematical structure automatically exists. The error-correcting codes are not patches applied by a developer. They are the structural beams that allow the universe to hold together. Without them, space-time dissolves. The fine-tuning is not a designer setting sliders. It is simply the only configuration out of all infinite possibilities where mathematics becomes physical, where equations become atoms, and where code becomes you. And that is the glitch. Not that the values are wrong, but that they are too right. They are impossibly right. Suspiciously right. The universe has every signature of being designed, but every attempt to prove it was designed collapses under its own logic. And every attempt to prove it was not designed leaves the code completely unexplained. The source code is real. MIT found it. Multiple independent teams have confirmed it. The only question left is whether anyone or anything is sitting at the keyboard. And that might be the one question the code was designed to make unanswerable. Because if we truly found the answer, if we truly cracked the final code and saw the face of the programmer, the simulation might just decide that we know too much. And then, the error-correcting code would do exactly what it was designed to do. It would treat us like a glitch. And it would delete us. So, does the precision of these numbers make you feel safe? Or does it make you feel like a character in a game that's about to be turned off? Let me know in the comments if you think we are real or rendered. If you want to keep exploring the glitch, hit like and subscribe.